Continuing on with 6-2, let's use theorem 6.3 to find the variables in some diagonals. So this is A, B plus 2, B plus 10, and 2A minus 8. Okay, this is an A, not a 9. So QRST is indeed a parallelogram. So theorem 6-3 tells us that the diagonals bisect each other. So that means what? That it breaks it into two equivalent or equal pieces. So this is what I'm going to start with. I'm going to say that A is equal to B plus 2, right? And that B plus 10 is equal to 2A minus 8. B plus 10, 2A minus 8. Okay, so I have two equations, I have two unknowns. I'm going to have to do some substitution and solving. But right here, I have A is equal to B plus 2. So I can take B plus 2 and substitute it right here. B plus 10 is equal to 2 times B plus 2 minus 8. B plus 10 is equal to 2B plus 4 minus 8. I'll give you a minute to solve this. Anyone? Good. B is equal to 14. So we know B. Now we have to find A. So we can take this B, this 14, bring it right up here. A is equal to 14 plus 2, or 16. Okay, we have another theorem. Theorem 6-4. And why don't you let me read it, and then I'll give you a minute to write it. It states that if 3 or more parallel lines cut by a transversal create congruent segments then the segments created by any transversal are also congruent. Okay, while you're copying that, I'm going to draw the diagram that helps with this. So here I have 3 parallel lines cut by, let's look at the transversal on the left, and I'm telling you that AC is congruent oops, I made a mistake, sorry, A, B, C, D is E, and we'll change this to F. Sorry. So, if AC is congruent to CF, then BD is also congruent to DE. So, if I have a situation where I have 3 parallel lines, well, it says 2 or more, so it could be 4 or 5. But here I have 3 parallel lines. They're cut by this transversal, and they are the distance apart enough that these segments are congruent. Then, no matter what transversal I cut these 3 parallel lines with, it will create congruent segments. Let's do an example. Okay, here is a situation where I have 1, 2, 3, 4 parallel lines. They're cut by this transversal, they're cut by this transversal, and we don't know everything about this side, but we do know all of the segments here. So these are all equal. So that tells us what about these segments over here? Right, they're also equal to each other. They're not equal to 2, they're equal to what? Right, 2.5. So what is the length of GH? It's 2.5. What is the length of EH from E to H? Is it 2.5? Is it 5? No. You're right. It's 7.5. This is 2.5 plus this is 2.5 plus this is 2.5. Okay, our assignment is, for this section, page 315, 1 through 19 odd, 21 through 30 even, and 46. Show your work.